that when you see a pattern of shots kicked in, you double the size of the buffer and validate, and then you simply pass back nothing, or you pass back data, and you make a decision model on it. So that was how I did a lot of when I did the streaming stuff.
Was that relevant to bitrate?
Yeah, so the way I did bitrate was, you basically would, the stuff was on disk, and so you start playing the game. And the game's like, I need to open this file at this offset so I can pull this mesh texture model, this like that. So I'd see read IO requests in the kernel. When they hit the kernel, I would then check against the table. And the table would tell me, hey, has this been downloaded or not yet? And if it was no, then it would hold the read IO thread. And then another thread would start to populate the data, including all related linkage data. And once it starts dropping it, then it would fill the memory buffer, close the loop, release the hook, and allow it to read through. So as far as the game was concerned, it was a slow hard drive. It had no idea that the data was missing the entire time. So I'd have games start with like 2% of payload. 50 gigs? Who cares? I'll start you at 1 gig. You're playing like the whole thing was there. Did that for years. Star Wars Your Republic still uses it to this day. People play that game every day. Like 50 million people. And so, but the thing is, there's a zero integration. Because you have to write your software to be able to handle slow read IO ops. Not every hard drive operates the same, right? SSD, NVMe, and all run different. So that's why it was done that way. You can do it in kernel space if you're actually trying to control it. And the other way that it'd be unbreakable was that I had, just say the algorithm was used, but when the data was brought in, it was encrypted. And because I had the different blocks that came in or not, I could actually pepper it. So that, yeah, some of the data is clear, some of the data is encrypted, some of the data is rolled, some of the data is dynamic. And so as a result, I would, in the kernel space, apply different keys over time that would roll it. So if you tried to capture the data, it just wasn't there. And then when you went back to the buffer, once I saw it go into the GPU, it wiped the back buffer on it. So you had actually, you couldn't pierce through GPU memory at the time. Sorry, I didn't mean to.
No worries.
Were you here the
No, I don't.
Oh, yeah, squared. That's right. Shit, I'm sorry, I forgot. I'm like, wait a minute. Yeah. No, yeah, that's so. I can dig deeper.
Okay, yeah, I would love that.
It was a ton of fun.
That kind of permission-based, system is what I think is, I love these conversations. I feel like it obviously the scale, but I feel like that plays a level where you have it.
Probably has security issues too.
In which part?
I don't know. You haven't described it, like to the point where I can.
Oh, I mean, the kernel. I mean, security. Obviously, if you break the signature model in the OS, then yeah.
Well, where's your key stored?
The key store. Say when you start up Windows, all those things are signed, and they all start up as a secure boot. That actually goes to UEFI.
But where's the signing key?
That's actually, the key is generated and stored in the BIOS and UEFI, from what I understand, because that's how you do a secure boot. And then the drivers then are applied against that, and that's how you're able to secure boot. That's how Windows keeps you from putting illegal drivers on. And so by signing your driver, you become part of that chain.
Okay, so you're tying it to the secure boot then?
You're always tied,
okay.
You're always tied into the secure driver.
But then are you always signing with a secure boot key, or are you signing with another key?
You sign with a Microsoft Authenticate and paired key that actually goes against their signature that they give you.
Okay.
Yeah, so you're in their secure chain.
How long did
I wrote this in 2011. It'll be a short session for you, man.
Yeah, I'm happy to answer questions or whatever. Like, it's just the three of us.
I missed your talk.
Yeah, I was expecting it to be. The last session of the conference is
it's
always super quiet.
Yeah. Yeah, it was kind of cool that with the authentication stuff. When you were doing your talk, there were definitely a lot of people that were like, hey.
Well, no one thinks about like privacy and confidentiality, and fewer people even define it. So like you have to define security. It's a,
Well, I guess if we think about this, though, on the authentication side, we're talking about defining the security of what the model is behind it. That's going to be, it's got to be the dig-in point, because, that's how I'm going to make sure you are the identity.
Sure, yeah. I mean, you have to, I don't know how much of this you all have seen, but you usually define security as a game, right? Where you have a challenger and an adversary, and, you give the adversary some capabilities, and then they have to, break something or do something in the end, right? And you show that generally if they can do this, then they're breaking some hard problem or some law of physics. So, and the same is true for privacy, right? And anonymity. You need to sort of specifically enumerate what, someone can do in a system to break this.
What were some of the models that you were thinking about, though, in regards to the authentication model itself? Like, how do we go from this, say, hey, yeah, it's really me. I mean, is my phone a part of that equation?
Well, yeah, I mean, I said in the presentation yesterday that sort of I was assuming you were your phone or your PC, because what
if I use his phone?
Well, then this is a much bigger problem than Metaverse, right?
Yeah, it is.
Presumably his bank cares more about that than than a Metaverse application today.
Bank?
So
I see your phone, man. No, I'm just kidding.
I was willing to.
Can I get your PIN, your bank account password, and your social security number?
Where do you see hardware tethering pertaining to identity management?
So that's a great question.
If I verify through the TPM that this is that particular device, but then obviously if I want to resell this, then that has to be logged somewhere. So.
Yeah. So I mean, hardware is a great solution. Not because it's super secure, but because it's relatively cheap in terms of efficiency, and it raises the cost of doing an attack, right? If your keys are stored in some hardware unit, then it's much harder to attack, right? I have to shine the laser on the hardware unit or whatever. These even the speculative execution attacks have gotten harder and harder to do, if you're familiar with those. So, and yeah, you have to have solutions you don't want to necessarily bake something into hardware. If you do, you're right, you need to have a way to update it, right? But the whole point of this stuff is you should be able to update your credentials anyway. And in sort of a dynamic world, they are going to be being updated constantly, right? And ideally, you're going to have some sort of threshold system, right, anyway, that's going to make updates pretty simple and seamless.
Do you think the hardware models we have now, like TPM, do you think they're secure enough for what we're going to be dealing with? Do you think they're able to handle some of the complexity of what we might be able to do, especially migration?
I mean, it depends, I guess. Think of a hardware wallet as securing some amount of value. You'd probably trust it with how valuable is your tracking data for people? It's valuable to Google and Facebook, but you're worth what, a few $100s to them or something, probably? I don't know exactly.
I want to feel like I'm worth more.
What?
I want to feel like I'm worth more.
Yeah, but you're probably not worth $100,000,
Right. No,
so,
I know what you mean.
Most of your data on the Metaverse is going to be low value, right? You're not likely to be making huge, probably not going to buy a house over the Metaverse.
Sure. Well, I mean, if we think about it though, if microtransactions keep happening, and we look at the volume of microtransactions in games, and the Metaverse becomes the next game, then it's not far-fetched to think somebody's going to blow 10 grand or more a year.
But
people already have blown.
Most of this is going to be in smaller bits, right?
Yeah, but microtrans eats a lot of cash, man.
It does, but the point is if something goes wrong,
right,
then there's an interval where it goes wrong, and I might be out $5, but I'm not out $100,000, right?
Yeah, I blow my Steam account, or I blow my WoW account, or you know, like my Blizzard account.
But how much?
I'm out probably 10, 15 grand because I've been playing with it for 10, 15 years.
Oh, but are you talking like your whole library and stuff?
Well, yeah, your library, or even what you've done, the characters and stuff that you've built. Like there's years of. We can't think about what will it be one day. What's it going to be after I've owned that thing for 10 years and 15 years? It's a lifetime of money.
Presumably, like, there's not going to be an easy way for you to do that in a low security way, right? Like, in today's systems, right, if you make a $100 purchase, your bank's not going to complain. If you this is why you have a credit limit, right?
Right.
So, like, there already are digital wallets that enforce these restrictions, and presumably sort of any kind of wallet you have or any service you have, you'll be able to do things like require like some kind of multi-authentication for large purchases or something, right?
But I'm not even thinking large purchases. If I spend $100 a month and I was on that account for 20 years,
or too many small purchases in a row, right?
No, just $100 a month. That's $1,200 a year, and after 20 years, it's 24 grand.
Sure.
It's not unreasonable.
But so how are you losing this?
Somebody pierces the account, someone wipes it, someone does something, pretends they're me, somebody authenticates like they're me.
But that should specifically be hard, right?
Should be. That's why I'm saying, how do we explore that? How do we prove it or debunk it? What's a good way for us to do that? How do we attack it?
How do you attack that?
Yeah, like, I mean, I live in a world where everything is fallible.
Sure. But I mean, the point is, like, what is someone like taking, this is a case of someone like taking control of your whole account, right?
I mean, listen, I used to be ICQ back in the day, all right? And when I denied a bunch of hacking groups from being able to actually steal a game that I had secured, they immediately tried taking over my email accounts, and they did take over my ICQ account, which I never got back, which I owned for 7, 8 years before that. And it had value to me.
Yeah, I mean, but if you thresholdize this stuff, you can recover, right?
That's the question. I mean,
like, if I would absolutely like thresholdize my account, right?
we need to define thresholdize.
So you basically split up the secrets among a bunch of different like things or institutions, and then if you want to like recover or update a key or something, I guess the identity folks yesterday were talking about like social recovery.
Yes, which
that's
was
like,
pretty cool, by the way.
And but this is like the sort of technology that would underpin that.
Right.
You don't have to just use it on people, right? You could have some other server or some other company, you could give them a share, right?
Yeah, that's true. Like, somebody could be a safe vault.
You could split it among your devices, right? And so that way, if like one thing got compromised, your whole, secret wouldn't be compromised.
Yeah, I guess as long as you're able to get to it. Like, if I have a Photon account, or was it Photon? The secure email service?
Yeah, Proton.
Proton. Right? So Proton, I give it a key, and it encrypts on my email. If I blow that key, I don't get my email back. It's all encrypted with that key.
Right.
I'm screwed.
Sure.
So I'm just saying.
But you could also like shard that key, which is the technical term, among.
As long as I do it beforehand.
Yeah,
so
yeah.
I can get it back.
But that would be like a part of the setup process, right? Is you would do this key sharding process, and then,
Yeah.
you
Well,
would
if somebody
have-
got in and they rolled my key, then I'd be out of luck.
They what?
They rolled the key.
Define rolled.
Created a new one to replace the old one.
Sure, but you could also have a key recovery process.
Not if it's a new key. If I literally, let's just say I had a key that was 1, 2, 3, 4. Somebody hacked, and I gave 1 to him, 2 to you, and 3 to him, and I kept 4, right? And then somebody went in and managed to hack their way into my account, and they got 1, 2, 3, 4, and then they did a change password on my account and changed it to 6, 7, 8, 9. My recovery of 1, 2, 3, 4 is never going to get that back.
But you could presumably have a higher authentication required to change the password, right? You could require like some kind of dual confirmation or something, right? You could require like.
So it's really dependent on, you're saying it's more dependent on the service to have these higher levels, but
Yeah.
how much is too much?
That's up to you. how much do you want? How much, like, if you're looking at, if you talk to like some of these like early rich Bitcoiners, they have all kinds of crazy processes for this, right? So I know a guy who like, where's the bank? It's Malta. So like the Malta National Bank, you know, has like one of his key shares, and every like so often he goes and from his like Bitcoin stash and he like allocates his like hot account more Bitcoin that he can spend, right?
Right.
And he has some kind of like, he has a secret split over, you know, lots of different things. One of them is on a titanium plate that he carries around that he shows off. It's,
That's
you know,
funny.
so some of these systems are like really elaborate. And this is one thing if you think you know, if you have tons of Bitcoin and everybody knows it, and you're worried about like, you know, not only being hacked, but maybe even people kidnapping you.
Yeah.
But, you know, for most people, this is massively overkill, right?
It is.
So, you know, it's up to you to sort of determine like what sort of.
I think the key is having something that is appropriate. The average person's not going to get into this, okay? They're going to ask their friend who's going to ask an expert or ask someone else. And so somebody eventually who is versed in this area will be rendering an opinion of some sort. You know what I mean?
But you can always put a prompt up to a user and be like, do you want to like, you know.
Same way that you invite people to the platform as you're signing up or something. You could say, hey, who are your best friends that you want to send this to?
Or do you want like, you know, it's more likely to be organizations, right?
But how is that managed if they're not, if those other people are not already in the network though? That's the interesting.
Like the people or the orgs?
Both. You
So
know,
the people I think
if
is
I want
like,
shard then.
I think the social recovery is a little bit idealistic because you do have to have those people in that system. What's sort of an easier solution is that you could have provider companies in the system, right? And you can set up a policy where like, you know, if like, you know, you need like 3 out of the 4 companies to recover or something, and assuming that like, you know, no 3 of the companies collude without your consent, they can't do anything either, right? So they don't own your data. It's distributed, and you know, you can recover that way. You like call them up or do something out of band, right? And that you can recover your account that way.
So you think just authentication wise, passwords are out of the loop here, or you think they're in the loop?
They're like for what?
Just for what would be on the metaverse, you think passwords, type in your 8-letter password is going to be, what do you think that kind of level of authentication will be, right?
I mean, I don't know what people will end up using. I mean, I hope it's something more secure than passwords.
What do you think would be good?
Like
That's not so over complicated.
some kind of multi-factor authentication, right? You know, like, you know, you don't, maybe like some light password for your device, but your device should have all of the, you know.
Okay.
And then you're stuck with the like authenticating your device to your device problem, but
Yeah.
again, that's like.
But that exists. We can do that.
Yeah.
And that's fine. It's not, we don't have to come up with something that's like theoretically, you know, we've never done it and it's not right. I mean, what we have stages that we have to go through this anyways. And what we have today is the reason for putting all this together, right? So that, I mean, that's a good point then. You know, multi-factor authentication, light password, things like that, where the actual password itself is something pretty complex. But by unlocking it through multi-factor and a light password on your device, you're...
Yeah, I mean, you don't want to have to type a password in every time, right? You don't, like, no sort of, like Google doesn't, no one makes you do this anymore, right?
No, I use my thumbprint for everything.
Well, that's a whole nother issue, but like the problem with biometrics is that, well, they can be a security layer. They should not be the only security. The problem is like once I have your thumbprint, you're just done.
Yeah,
like,
that's true.
You're done forever, basically. And sort of like, you know, server A might do a good job of keeping your thumbprint secure. But some other person might store it in the clear and it might get compromised, and then like
maybe we just need to pick something more transient, like, you know, I don't know.
Well, how much does hardware come into authentication in terms of like different signal input? Like if we do use thumbprint, maybe one way of verifying that it's your current thumbprint, which thumbprints don't change, but what I mean is that it's currently your actual thumb on the device and not something that was put there, you know, through, you know, exfiltrating your thumbprint and then putting it there digitally.
Yeah, that is great for a lot of applications. The problem is a lot of these hardware systems can be compromised. So if I like wanted to like swipe your phone, if your phone had some system like this, right? And I wanted to swipe it like and put my thumb in quickly, you know, it probably would stop that, and that's a good thing. If I had like, you know, a weekend with your phone in a state-of-the-art lab, you know, it might not be so good. But yeah, I mean, these, like, again, biometrics are like they're a layer.
Once they get pierced.
They can be a whole layer.
Yeah.
Because you can't regenerate them.
Yeah, like if I have your thumbprint and I can like, you know, print it to a paper, which like people have done this, right?
Oh, yeah.
You can like, there are 3D printers that'll print like, they print it to like a clay-like substance,
Yeah.
I believe.
But if I have your thumbprint and a password, you know, put your thumb,
Yeah, but
some kind of combination.
But this thumbprint, like, it will stop like random people, right? Like if I'm like, Royal's phone is extremely valuable.
Yeah, exactly.
Yeah.
It's not going to stop.
That's the thing is that I was having a conversation with a couple people about digital scarcity, whether or not ever that might be something that could be tenable, and what would that look like? And you know, when it comes to that, you're always going to be vulnerable if somebody has your hardware, right? There's too many ways to.
It's very hard.
And so, but how much of the conversation should we have about every single edge case versus what are the majority of the situations going to be? What is the 95%? What is the the 80%?
This is a defining a security model question, right? Which is exactly what needs to happen. Like, you know, and it's probably not just one. It's probably like a handful, right? But yeah, it's exactly like.
That's a good call to action right there.
Picking the right security model, right? And you don't want to pick too much security. Like, people starting like, I want all the security. No, you don't. Yeah. It's not efficient, right? But yeah, this is a challenge. Is like, what's the right security model for various different things? And this is always a hard problem in practice.
Yeah, and when it comes to the metaverse, you know, figuring out what that security model is going to be tricky because we've already discussed there's going to be different metaverse layers, different, you know, technologies that get adopted in different.
I mean, more like, like
speeds
if you're wearing a headset, it's most likely going to have a camera that's inward facing, which is
right
in your eyes.
Right, and so. You know, but if we want to have, you know, an ecosystem where somebody owns something, you know, if there's any weak point in that, in a security model, then, you know, it kind of defeats the whole point.
Yeah, I mean, this all just has to be carefully thought about. And all the data, you know, all like the camera in your eyes, all that stuff, right? You know, it needs to be thought about. Like, what's the model on that data? What do you not want someone to learn, right?
Yeah.
So what do you not want? Yeah, it's a complicated thing, and like it's a little bit scary in some respects, right? That if people don't think about this and this data is just kind of there, you know, it's interesting. It's a tough problem. And people like don't think about like, you know, can you define privacy? Can you give me a privacy definition?
Right. Yeah, that's a good point.
Anyone?
No, it's true. It's just a subjective of what I asked the other day when I said define the internet. No, give it to me in 10 words.
The internet?
I'm sorry, metaverse, the metaverse.
Oh, I'll be, yeah.
We got 5 answers.
Yeah. Well, but privacy, you should have a different answer, right? But I'm asking for any definition of privacy. So, like, it's hard. If you go back even to, like, have you all seen differential privacy?
No.
So it's sort of a notion about how to quantify, like if I release a data set, how much does it reveal about an individual person?
Oh, yeah.
Oh.
Or like how many degrees of separation is there until you know more about that person or something like that?
Not exactly, but sort of.
Or like, you take this piece here and it's anonymous, but if you couple it with this other data, then.
Well, it's basically if I know something about you, right, or then I have a data set, even if it doesn't have your data in the clear, if it uses your data as some kind of input, like what can I learn about you? And sort of the rough answer is how much does your individual data change the overall data set, right? If you're an outlier and like, if it's like, let's take the average net worth of like the three of us and Bill Gates, that reveals a lot about Bill Gates' net worth, right? It's not very private, even if we've given an average.
Right.
Right.
But if there are a lot of people sort of in the same, like, that are distributed very similarly, if you like take one person out, like if you're not in the database versus if you are in the database, it looks kind of similar, right? And that's kind of how differential privacy works.
Yeah, okay. Gotcha.
And it's used in some cases. It's actually very hard to use because to be meaningful, you have to sort of have a very like homogeneous distribution. But like the U.S. Census uses it.
Okay.
Gotcha.
But then this is just a totally non-interactive database. Once you start talking about interaction and being able to track people interacting, it gets even more complicated. So like, even if you're anonymous, if I see some like interaction patterns that I can correlate, like, are you all familiar with Zcash?
Yeah.
It's pretty much completely de-anonymized because people don't use shielded transactions for everything. A lot of people that do use shielded transactions transact in very particular patterns. And so it's very, it's very easy to trace things, even though it's ostensibly anonymous.
Gotcha.
So, and people run forensics on this. There are entire companies that run like on blockchain forensics.
Trying to figure out who's the whale and everything.
Right.
And you can bet if you're like a decent advertiser, like there's value in this, right? If you can like run a large scale de-anonymization. Like one of my friends did this hilariously. This was years ago, but do you remember the Netflix challenge? Where they like gave a data set.
Oh, yeah.
And they asked people to predict, like, they're like, here's a user data set. What will people like in the future? And the idea was you could improve their machine learning algorithm. And so this guy basically realized that he could link people in the Netflix database to their real life IMDb database, and then just read off how they rated the movies on imdb.com.
That's funny.
And so he had a string of very successful machine learning challenges by de-anonymizing people. Right? So like, there's definitely value in this.
That's funny. Yeah.
Interesting.
Cool.
So anyway, I think I'm close to time. And
Yeah.
You all
Yeah.
should have my email, so you can talk to me
Yeah.
Cool.
at any time you want.
Yeah.
So
Appreciate it, man.
yeah,
That was
thanks.
actually pretty good. It was good kind of going down that road a little bit.
Yeah, I agree.